We have a calculator in one of the Trees and Design Action Group guides. I think it's Trees Planning and Development. And I think it shows that if you take out a relatively mature tree, that's just existing naturally, it's very happy, that it will take 90 years for another tree to, was that an acorn?
Yeah.
It will take 90 years for another tree to grow and provide that same benefit. So, there's this big campaign to plant more trees, get new trees into development, and all that's absolutely right. But it needs to be, we need to retain our existing trees, because if we retain our existing trees, we don't need to plant more. And perhaps some of the funding that we currently have from the Nature Climate Fund and other sources for getting new trees into the ground could be repurposed for protecting those trees that we already have.
Yeah. Really important to protect the trees that we have. And that whole area of how the built environment would view something like this and think about it as a starting point for some infrastructure project. Of course, in the past, the cheapest thing to do is just to raise everything, completely flatten and grade your ground, and then as an engineer, you just impose, everything is imposed from you. And I think we really have to get away from that imposition and start working with what we have already. It's incredibly important in the urban environment. This is actually a really good example of how it can be done, because there are no concrete foundations in our experimental patches. There are no gaps that were created in the canopy. Because they use the existing. You can see even here there are lighter patches and darker patches, so natural occurring patches of gaps and so on. And that's what we need to be encouraging the built environment to think about. What have I got here? What a resource. The other side of what you've both been talking about just now that comes to mind is this: when it comes to what benefit am I getting from this green infrastructure as a grey infrastructure owner? There are those two sides. There's the immediate climate impact or impact on heat transfer. The heat balance, the temperature, the whole thing, and also water transfer, as you were just saying, Emma. And then there's the longer, slower net zero question. And for that, you need to know where your carbon is being locked away. And even old trees, they are a brilliant solution, but they are only century scale solutions, 100 years, many decades to 100 years, a couple of 100 years. For climate, we need to be locking carbon dioxide away for many, many hundreds of years, thousands of years. Forests can be really important in that by building really long-term carbon stores in the soil. Other trees in other places can also do that if you give them the opportunity and if they're allowed the time to do that. But then the shorter term carbon story, by which I mean even things like the stem of a tree, we need to do something with that carbon, put it away, let the forest continue to grow. I don't mean flatten forests. I mean, take wood carefully out of forests, use it. Be fantastic if we used more of it for building. But I think in the end of the day, that's not going to soak up enough carbon. We're going to have to end up putting it either as wood or as burnt, as CO2, so burn the wood, capture the CO2, and then pipe that down into where the fossil fuel was, so carbon capture and storage. I think in terms of really getting on top of climate change, trees have a really important part to play, but we must not think of them as a silver bullet. Otherwise, we're going to kid ourselves that we've done the job.
Yeah, and as you said, the time frame is just too long.